Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x plus y is equals to 5 and xy is equals to 10, and we solve this problem for all the values of x and y. So here first we call this is our equation number 1 and this is our equation number 2, and we solve these two simultaneous equations and we easily get the values of x and y, and at the last we will be verify that which of the values of x and y are solution and which of these are extraneous root. So for verification, for solution of this problem, we need the very first step we are going to do is first we focus on equation number 1, and our equation number 1 is implies that here we move the term x from left hand side to the right hand side, and we get the value of y is equals to 5 minus x, and we call this is our equation number 3. So further in the next step, here we substitute this value of y into the equation number 2, and equation number 2 is implies that this is xy equals 10. The value of y is 5 minus x is equals to 10. So we need little bit more simplification, and we convert this equation into the quadratic form of x variable. So we multiply x on both of these two terms, and it will becomes 5 times of x minus this is x times x becomes x square is equals to 10. Further, we move the both of these two terms to the right hand side, and it will become this is negative x square. When we move it into the right hand side, it becomes positive x square. This is plus x becomes minus 5x, and this is plus 10, and this whole equation is equals to 0. So further, you see here, we need to solve this quadratic equation. For this we use here the nice quadratic formula, and for this we write the coefficients of this equation, and its coefficients are a is equals to 1, b equals to minus 5, and c is equals to 10. This is our quadratic formula, and here we substitute all the values of a, b, and c into the quadratic formula. But first we state the quadratic formula as minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. This is our quadratic formula, and here we substitute all the values of a, b, and c in this formula, and it will becomes x is equals to this is minus b, the value of b is minus 5, plus minus square root of b square. B is minus 5 square minus 4 times of a is 1, and c is 10, and it is divided by 2 times of a, and here our a is equals to 1. And further we need more simplifications, and we obtain minus times minus becomes plus 5, and plus minus square root of minus 5 square becomes 25. 4 times 10 becomes 40, and it is divided by 2 times of 1 is equals to 2. So further here we need to simplify these terms. So when we subtract these two values, we will obtain here 5 plus minus square root of minus 15, and it is divided by 2. So here you see that negative sign appears inside the square root sign. So we have we write this negative sign is equals to iota. So we have 5 plus minus square root of 15 times of iota, and it is divided by 2. So this is the value of x. And now further, for these two values of x, we need to find the value of y. So that we need to copy down equation number 3 here. So equation number 3 is implies that y is equals to 5 minus x. So in this side we will be choose the positive value of x. It is 5 plus square root of 15 times of iota, and it is divided by 2. And in this side we will be choose x is equals to 5 minus square root of 15 times of iota, and it is divided by 2. So we need more simplifications here. And now we substitute the values of both of these two values of x into the above equation, and it will becomes y is equals to 5 minus x. The value of x in this case is 5 plus square root of 15 iota, and it is divided by 2. So we need to take the LCM of this term, and its LCM becomes 2, and we get 2 times 5 becomes 10, minus this 2 and 2 are gone, and we obtain minus 5 minus square root of 15 times of iota. So we need more simplifications here, and it will becomes 10 minus 5 becomes 5 minus square root of 15 times of iota, and it is divided by 2. So this is the value of y corresponding to the value of x is this one. So in the same pattern, we need to verify the second value of x. So we put this value of x here, and we will get the value of y is equals to 5 minus x. The value of x in this case is 5 minus square root of 15 times iota, and it is divided by 2. So further here we need to take the LCM of this term, and its LCM becomes 2, and we obtain 2 times 5 becomes 10, and we multiply this negative sign on each of these values. These 2 and 2 are gone, and we get here minus 5 plus square root of 15 times of iota. So this is the value of y. Finally, we have y is equals to 10 minus 5 becomes 5 plus square root of 15 times of iota, and it is divided by 2. So these are the second value of y, and corresponding to the value of x is we will write it here, that is 5 minus square root of 15 times of iota, and it is divided by 2. So finally we have there are two roots of the given equation, and these two roots are in the form of ordered pairs of x, y. So the first order pair is the value of x is 5 plus square root of 15 iota, and it is divided by 2, and the corresponding value of y is 5 minus square root of 15 iota, and it is divided by 2. So secondly, the second order pair of solution is 5 minus square root of 15 iota, and it is divided by 2, and the value of y is 5 plus square root of 15 iota, and it is divided by 2. So these are the two values of x and y which we obtain here. And now further in the next step, we need to verify that is these roots with a solution, or is these roots with the extraneous root. So for verification of this, here I can just verify only one root, and I can left the verification of other root for yourself. So I can verify this root, and I can left this for yourself. So for verification, we need to copy down given equations. The first equation is x plus y is equals to 5, and the second equation is xy is equals to 10. So for verification of this, we have the value of x is equals to 5 plus square root of 15 iota, and it is divided by 2, and the value of y is 5 minus square root of 15 iota, and it is divided by 2. So here first we substitute both of these two values of x and y into the first equation, and it will becomes 5 plus square root of 15 iota, and it is divided by 2 plus 5 minus square root of 15 iota, and it is divided by 2 is equals to 5 or not. This is our claim, and when we put both of these two values into the second equation, it will becomes 5 plus square root of 15 iota divided by 2 multiplied by 5 minus square root of 15 iota divided by 2, and this is equals to 10 or not. This is the our second claim. So here we simplify both of these two roots, and here in the left hand side we take the LCM of this term, and its LCM becomes 2, and we obtain 5 plus square root of 15 iota, and 5 minus square root of 15 iota is equals to 5 or not. This is the negative term, positive term are gone, and we get 5 plus 5 becomes 10 over 2 is equals to 5, and 2 times 5 becomes 10, and we get here 5 is equals to 5. This shows that both of the sides are equal. And now here it should mean that the value of x and y satisfied our first equation. In the same pattern, we verify second values, and here we use the nice algebraic formula to the numerator terms, and we write it as 5 square minus the square root of 15 iota and its whole square divided by, this is 2 times 2 becomes 4 is equals to 10 or not. This is our claim. So this 5 square becomes 25 minus these 2 and square root are gone, and we get 15, and this square of iota becomes iota square, and we know that iota square is equals to minus 1, and it is divided by 4, and we check that is this equals to 10 or not. So we have this is minus 10 minus becomes plus, and we get here 25 plus 15 divided by 4 is equals to 10, and 25 plus 15 becomes 40 divided by 4 is equals to 10, and we get 4 times 10 becomes 40, and we easily get here 10 is equals to 10. So this means that the first order pair satisfied our both of these two equations, and in the same pattern we verify the second order pair, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more interesting and exciting videos.